Okay, folks, let's calculate original oil in place. Step 1. Multiply the area in square feet by the reservoir thickness. Step 2. Multiply the answer by porosity. Step 3. Multiply the answer by oil saturation. Oil saturation is 1 minus water saturation plus gas saturation. Step 4. Your answer is now in cubic feet, so divide by 5.614 cubic feet to convert to barrels. Step number 5. Your answer is original oil in place. Please remember that the porosity and water saturation might not be given to you. As such, you can calculate porosity from the sonic reading, and you can calculate water saturation from the deep induction resistivity curve. Okay, now that we know how to calculate original oil in place, let's calculate stock tank barrels. Step 1. Multiply original oil in place by the recovery factor. Step 2. Divide your answer by the formation volume factor, B sub O. Your answer is stock tank barrels measured in barrels. Important definitions: oil formation volume factor, B sub O, is defined as the ratio of the volume of oil plus gas in solution at reservoir temperature and pressure to the volume of oil at standard conditions, so-called stock tank barrel. Recovery factor, the percentage of oil that can be produced from the reservoir. Let's look at a problem. Let's calculate stock tank barrels in a newly discovered field that has an areal extent of 3 million square feet, with a reservoir thickness of 25 feet, where RO is 0.25, RT is 7 ohms, delta T equals 95 microseconds per foot, and the formation volume factor is 75%, and B sub O is equal to 1.1. We'll assume this is a South Louisiana sandstone formation. Step 1. We'll take the area in square feet and we'll multiply it by reservoir thickness in feet. So 3,000 times 25 equals 75 million cubic feet. Step 2. We'll multiply the answer by porosity. So we'll take 75 million cubic feet and multiply it by delta T log minus delta T matrix divided by delta T fluid minus delta T matrix. So we have 75 million cubic feet multiplied by 95 minus 55.5 divided by 189 minus 55.5. Our answer, 75 million cubic feet multiplied by 0.3 or 30% equals 22,500,000 cubic feet. We round porosity to the nearest whole number. Now let's look at step 3. We multiply by oil saturation. Oil saturation is equal to 1 minus water saturation plus gas saturation. So we take 22,500 cubic feet and multiply it by S sub O. We come out with an answer of 22,500 cubic feet times 0.81, which is the oil saturation, and we get an answer of 18,225,000 cubic feet. Okay, your answer for step number 4 is now in cubic feet. However, we measure oil in barrels, not in cubic feet. So we divide by 5.614 to convert to barrels. So we take 18,225,000 cubic feet and divide by 5.614. Our answer is 3,246,348 barrels. Be sure to round off to the nearest barrel. Step number 5, 3,248,348 barrels is original oil in place. Now it's time to calculate stock tank barrels, as it is impossible for us to pull all of the oil out of the ground and bring it to the surface for use. First step, step number 1, multiply oil in place by the recovery factor. Step number 2, divide your answer by the formation volume factor. Your answer then will be in stock tank barrels. Let's work this problem. Step number 1, multiply oil in place by the recovery factor. So we take 3,246,348 barrels and we multiply it by a recovery factor of 75%, 0.75. Our answer is 2,434,761 barrels. Step number 2, we know that because oil often has dissolved gas in the oil at reservoir pressure, as we move up the hole, we hit the bubble point, the point at which the pressure decreases enough where the gas begins to separate from the oil, and by the time we get that barrel of oil to the surface, it's no longer a barrel of oil. So we divide by the shrinkage factor called B sub O. We take 2,434,761 barrels and divide by 1.1 B sub O. This gives us a stock tank barrel calculation of 2,213,419 stock tank barrels.